Welcome everyone. So this is our 91st live stream geometry. We have 3 other people here with us currently, and I'm sure more people will join in a little bit. So today I'm doing more problems from the usual geometry discussions and problems Discord server. So that has just so many good problems that I've used it for many sessions for now. And I've been waiting for the problems from the Iranian Geometry Olympiad to be released. But they haven't been released yet, so I'm going to continue with this for now until that happens. So if you'd like to join us in the future, feel free to email me at mgreenb801@gmail.com. It's in the description of my video. We meet every Sunday at 8 a.m. US Central Time. All right, so I'm going to share my screen, so give me just a moment. Can you all see it? All right, I'm assuming it's a yes. All right, so here is the first problem. So we have a triangle ABC. P is the antipode. So basically that means AP is the diameter of the circumcircle. So let's draw the circumcircle. And the center of it, we could call it O. And if we reflect A about O, we get point P. All right, so this is point P. And then we draw BP and CP. So I'm going to draw rays. And we want to see where the perpendicular bisector of BC meets those two. So I'm going to draw that in. So we could draw these 3 points. This I could call M. Yeah, I'm not going to draw that point in, but okay, so E is on BP and F. I'll just leave that as D. So those are collinear. So I'm going to make this look a little nicer. All right. So we have this and this and this and this. Okay, so yeah, obviously these are right angles. AP is a diameter. And we draw the circumcircle of PEF and it intersects AB at X, or it intersects a circle at X. And then we draw the orthocenter of PEF. And we want to show 2 things are isogonal. So let's draw the orthocenter. All right, so this is it. So basically we want to show angle BAX is equal to angle CAH. All right. So how should we do this? It's got kind of a nice diagram. I wonder if A, D, and H are collinear. It almost looks like that's true. It does look true. So I see that Yash just joined. So thanks for joining, Yash. Yeah. So yeah, A, D, and H are collinear. I don't know why, but it's clear from GeoGebra that they are. So can we prove that? And maybe that will help us solve the problem. Because if that's true, then we just need to show AX as a symmedian, right? So yes. So yeah, how could we show maybe we could start out trying to show AX as a median. I guess we could prove either one in either order. And that's the same as showing ABXC is harmonic. So what's a good way to do that? Can we project through something? Maybe we could project through P onto this circle. We could try that. PEF and ABC are similar. Interesting. Okay. So that looks useful. And I wonder if EXF is similar to BPC. No, that doesn't look true.
I was like thinking of extending line XC and intersecting it with the circumcircle of ABC. Because like
Okay. All right, let me try that. So I draw XE and I draw that point.
Yes.
Okay.
Then that should be the B antipode.
That should be the antipode of B?
Yes.
Okay. Interesting. PH is parallel to BC. That's true. PEF, yeah, PEF and ABC are similar. Is it easy to show that this is the antipode by like an angle chase?
Yeah, like that's basically PXE is like PFE and that is like angle C. So like the chords PG and AB are equal. Then they are basically rectangles because P and E are like antipodes.
All right. Very, very cool. So yeah. So yeah, angle PFE is PXE, which is PXG, which is PBG. Okay. So yeah, of course we could do the same thing with XF if we wanted. And that should be the antipode of C. And it looks like we have another person joining. Hi, Prem Joshi, thanks for joining. So yeah, just a heads up, yeah. All right, add the orthocenter, then O and E are symmetric with respect to M. Okay.
AX is median by Pascal.
Oh, really?
Yes, like basically Pascal on XGB and BPA.
And BPA. Okay, so by Pascal, AX is a median. So what 3 points are collinear?
Can you write like the 6 points?
Sure. 1 sec. So say it one more time.
XGB.
Okay.
BPA.
BPA. Okay.
Yes.
Okay. All
Basically,
right.
that means like the line OE, which is like the perpendicular bisector of BC, and the tangent at B and AX concur. So basically, AX is the C median.
Okay. So the tangent, let's draw this. There we go. Okay. So if we draw the tangent at B and this line and AX concur. Okay.
Yes.
All right. So that proves that AX is a median. Let's move this up just a little bit. Okay. So I am gonna draw in that point, and then I'll make the diagram look a little nicer. Just a second. Okay, so basically K, we're saying K, E, and K, E, and O are collinear because A, P, and B, G meet at O. Okay. It's very cool. All right, so we know AX is a symmedian. So we just have to show that AH is a median. And that will solve the problem. And yeah, this looks very familiar. So I wouldn't be surprised if I've done this before on my channel. So the ratio of similarity PEF versus ABC. Yeah, we could try. Is OP tangent to PEF? Let's see. Let me do it this way. It looks like it is. So I could move things around a little bit, but yeah, so it looks like it is.
That is like obvious angle change.
Okay. Yeah, because this angle, as long as this, well, because angle APB is ACB, and so since that's equal to this angle, yeah, that's kind of obvious. Okay, so PX is also a symmedian. I don't see, because they're similar quads. Oh, ABXC and BEXF. Okay, so PX is also a symmedian. Interesting. So if we draw the orthocenter, we know that B and P are collinear. I wonder if that could help at all. So I have one idea. So if we drop perpendiculars from AB from D to AB and AC, and then we do the same with H, we could try to show the ratios are the same. And the perpendicular from H to AC is parallel to PJ, and the perpendicular from H to AB is parallel to BP. So maybe that might help. So actually, let's see. So yeah, if I drop a perpendicular from H to AC, is there anything I could say about the distance HL? And then I could do the same from H to AB and maybe try to pick a ratio. It's just an idea. I'm not positive it'll work, but. And then we also, yeah, so we have this. HP is parallel to BC, so that might help. Because if I draw this perpendicular, X is this spiral center of the spiral similarity. So yes. Oh, one sec, guys. I'll be right back. Sorry. All right. Thanks for waiting. Sorry about that. Let me check. All right, so X is the center of the spiral similarity because it's the intersection of the two circles. Now, if I drop a perpendicular from H to AB, let's see. Can I find HL over HM? Because I know they're both parallel to those two. Is OP tangent to PEF? Yes, it is. Yeah, you can prove that with an angle chase, but yes, it is tangent. All right. So HL over HM. I want to show that AD and H are collinear. Is there any way that I can find HL? Well, actually, yeah. So if I draw the phi to the altitude of this, HL is just HL is just CN, right? and HM is just BQ. So I want to find CN over BQ. The midpoint of EF, okay. We call that R. So let's see. Suffice to show that the orthocenter of PDR is H. Interesting. PEF and ABC are orthogonal. Okay. Yes, because, yeah, this is tangent. So you just move this a little bit higher. But I think, like, so we want to find CN over BQ, but we have CN over NF is OF over EF. Yeah, I think this might solve it actually. So CN, let's see, CN over CF is OE over OF. All right, looks like Nguyen just joined. We need to prove RH and VP are perpendicular. All right. That also follows by similarity. Okay, so you think you've solved the problem. All right. Okay, so thanks for joining Nguyen or Khan. So it looks like we just solved this problem. I had another idea, but they beat me to their solution, so I'm gonna write up their solution. So yeah, first we'll show that AX is a symmedian, and we'll do that using Pascal's theorem. So yeah, I'll hide the stuff I added. I think there's a way to prove it with the stuff I added, but their solution looks simpler. So let me hide all this. All right, so I'm gonna hide that, hide this. Yeah, let me know if you want me to keep any of these points. So I added an R. Okay. Okay, so let G and I be the antipodes of B and C. And what was collinear? So G, E, and X, and I, X, and F were collinear. Okay, so, and then we use Pascal. So
we don't really need like the point I.
we don't need the point I. Okay. So let G be the antipode of B. So by Pascal's, so let D be the midpoint of BC. Okay. And by Pascal's theorem, I'll say let OD meet the tangent to ABC at B at K. So by symmetry, CK is also tangent to ABC. Sorry, I know this might be, a lot of this stuff is obvious, but just writing it up for the viewers. ABC. Okay. And then we can use Pascal's on this. So first, G, E, and X are collinear by an angle chase. So G, E, and X are collinear by an angle chase. And I'll write this out quickly. Since angle PXE is PFE which is equal to, I mean, it's not hard to see that that's angle ACB, right? So yeah, I'm just going to write is equal to A.
So the chords like PG and AB are equal, and so AB PG is a rectangle since A and P are antipodes.
AG PB is a rectangle. Okay, so that's a rectangle. So does that prove that these are collinear, or that's just another fact that's the next fact?
Oh no, that proves these are.
Okay, because once we know these are collinear, once we know this is a rectangle, then
Since A and P are antipodes, so like they meet at the midpoint, which is
okay, so that proves that G, E, and X are collinear.
Basically we define G as EX intersection ABC. So we are proving G is the antipode.
Oh, so you let EX intersect it, and then okay, so let XE. So I'll write it like that. Let XE intersect ABC at G. So yeah, I thought of it a little differently, but this works also. Okay, so once we do that, it's easy to show that ABPG is a rectangle. So basically, rectangle implies G is the antipode of B. And so we know it's a rectangle because, is it because like we calculate angle AXE?
We have angle PXG is equal to ACB. So PG and AB are equal chords.
Okay. Angle, you said angle AXG. So what are those two angles again?
PXG.
Okay, PXG. So angle PXG is APB. All right. Okay, so, all right, so that now we can use Pascal's. So by Pascal's, whoops, theorem on X, then we have O, what was it? O, K, and E are collinear. And that means that once we know that, that means that AX is median. So it's a median. Okay, now we want to show AH is a median. And so how did you do that?
Since like both the figures are a 90-degree rotation and a dilation of each other, so
Okay.
like the corresponding segments are perpendicular to each other.
Okay. So, and what are the two corresponding segments? Forgot. So you define point R, right?
Like it was Ravi's idea, but like R is the midpoint of EF, and we want to show that H is also the orthocenter of PDR, and like PH perpendicular to DR is obvious, and then we show RH is perpendicular to DP, and that is obvious because like we know the antipode, orthocenter, and midpoint are collinear, so HR and DP are corresponding lines, and so they are perpendicular. And so we know.
So I'll draw the orthocenter of ABC. I see what you're doing. So let's do triangle center A comma B comma C comma 4. So we'll call that T. So DT is perpendicular to HR. So that's basically the idea that you're using, and you're also using that TD and P are collinear. So that sounds good. All right, so let me check. All right. So let R be the midpoint of EF. And then we want to show, so PH is perpendicular to DR. So yeah, PEF is similar to ABC. We'll say a spiral similarity about X with rotation 90 takes triangle PEF to triangle ABC. And that means that RH is perpendicular to DT. And that means that RH is perpendicular to DP. And then PH is perpendicular to DR, so we know that it's the orthocenter. So PH perpendicular to DR, that means that H is the orthocenter of PDR. Oops. And once we know that, then DH is perpendicular to PR. So let's see. So we have DH is perpendicular to PR. And is it obvious that AD is perpendicular to PR?
Like PR and AD are corresponding segments in the similar triangle. So they are obviously perpendicular, and now DH is also perpendicular. So ADH is collinear.
Okay, so PR corresponds to AD.
Like the
Implies,
medians.
yeah. So PR and AD are corresponding. Implies PR is perpendicular to AD, and that implies okay, so this implies DH is perpendicular to PR. So this implies AD and H are collinear. And then from there, AH is a median and AX is a symmedian, which solves the problem. So AH is a median, AX is a symmedian, and that means that AX and AH are orthogonal. All right, I love this. I love this proof. This is really nice. So thanks for that, and I will move on to the next one. So yeah, it took me a little while to write it all up, but yeah, it was we solved it pretty quickly. All right, so here is the next problem. This one I think is a little harder. So we have a triangle ABC with circumcenter O. Again, more symmedians, yeah. So again, we have symmedians. And let's see. Draw the tangents at B and C. Yeah, that was the first one. So this is the second one. Tangents. Okay. So we have a harmonic quadrilateral. This is L. And then what we do is we draw the parallel to the symmedian through B and C. And we see where that intersects the circle. So that's at X and Y. And M and N are the midpoints of AC and AB. This is M, and this is N. And we want to show that O is on the radical axis of two circles. So LNX and LMY. So yeah, we want to show that the center of this circle has the same power with respect to both. So yeah, I don't even know if we really need to draw these two circles. Because yeah, they're really big and clunky, a little bit clunky, but all right. Let's make this a little nicer. Let me shrink this a bunch. There we go, something like that. Kind of like that. So all right, so bx, cy, and we have point D. So we want to show O has the same power with respect to those two circles. So whenever I have three parallels like this, sometimes I find it's like easiest, like what if we reflect everything across the perpendicular bisector of AL? So this reminds me of another video that I did. BXYC is isosceles, because yeah, those two are parallel. But let's try something. So I'm going to take like the whole diagram and reflect it across the perpendicular bisector of AL. So I've done a lot of, I think my video of IMO 2019 number 6, and I also had another video that was the same idea. So I wonder if it works for this problem. Let's see. So let's draw the perpendicular bisector of AL. And if we reflect over this, B and X get swapped, A and L get swapped, and we have to see where N goes. So N goes to N prime, and M goes to M prime. O stays at O, and so it's the same. Basically, we want to show that, so this is, so instead of, it would be Bn prime A and Cm prime A. It's the same as showing that O lies on the radical axis of those, right? N goes to N goes to the midpoint of XL. Whoops, sorry. So yeah, basically we just draw XL and YL. And we take the midpoints and we have to show that O lies on the radical axis of those. Wow, this segment right here just goes through so many things. So yeah, we can hide a lot of the diagram. Like once we know that, yeah, I just had that idea because I used it in 2 other problems on my channel. So, oh, whoops, I wanted to hide the other circles now. So now I want to hide this and this, and we can hide N and M. Oops. So A, B, N prime and A, C. And then maybe we can use Casey's theorem. Yeah, well, do we need M and N? Because, well, what will we do? But we can prove that but once we do that, we can prove that N prime is the midpoint of XL, and we can prove that M prime is the midpoint of YL. So basically we proved that, it's not too hard to prove because it's just true by symmetry. Since n is the midpoint of AB, n prime is the midpoint of XL. And once we do that, so then we can hide n and m. Yeah. Okay. So we want to show that O has the same power with respect to these circles. And yeah, maybe we can use Casey's theorem. So the radical axis of these two is AB. Yeah, I like that idea. So let G be the center of this circle and H be the center of this circle. So the difference between the powers of O with respect to this circle and ABC, it's twice OG times the distance from O to AB. And okay, so actually now we can draw back in N and M. So really we want to show, I think we want to show that GNMH is cyclic. Let's see. Yeah, if we can show GNMH is cyclic, that would solve the problem.
I'm sorry, but we need to prove what is cyclic?
GNMH. Let me see. How's it equivalent? So there's one way that I thought about it, but now I think I might actually have a different way. So, so if we draw this, let me see if I could do it this other way. So GH is perpendicular to AI. And if GNMH is cyclic, I think we could show, so GH is perpendicular to AI. And then, let me think about this. So I have one proof, okay, all right. Is it like AO? Okay. So I have one proof using Casey's theorem, but I think there's a, so Robbie, do you have a better way? So GH, let GH intersect AO at R, then GNAR is cyclic. Okay, so if those two intersected at R, GNAR is cyclic. Well, How would you know that GNAR is cyclic? Oh, if GF and OA were perpendicular. Okay, so if they were perpendicular, yeah, okay. So yeah, that's what you're saying, yeah. Okay. I thought about it using Casey's theorem, but that's way simpler. But are those all if and only ifs? So like, so let's say we could prove.
But it is not equivalent, right?
Yeah, I don't know if it's an if and only if. So like I found a different way to prove. Here's my idea. So, so basically, I'll write it out in the chat. It does work. So, but yeah, I think Khan has a way of thinking about it. But here, so I was thinking about it like this. I'll put it in the chat.
Just explain it how Ravi does. It is true. And all you can use Casey theorem like Michael says.
Yeah. So power of O with respect to ABN prime minus the power of O with respect to ABC. It's twice OG times ON. So that's Casey's theorem. It says the difference between the power of a point with respect to two circles is twice the difference between the distance between their centers times the distance from the point to the radical axis. And then you'd also have let's see, AC. So that's 2OH times OM. But yeah, I feel like there should be another way besides using Casey, but I don't know. So yeah, because like so ANOM is cyclic. So like from there we might be able basically the angle we can find like the angle AO makes with MN. And then if we knew that GNMH was cyclic, since we know the angle that AO makes with MN and MN is anti-parallel to GH, then I think like we should be able to show that AO is perpendicular to GH if we showed that, but. I wonder if we can say anything about like, so I wonder where the center of GNMH is. Okay. Let's see. So yeah, how do we use that n prime as the midpoint of XL? Well, yeah, once we could show this, we're good. Let's see, XL by XC bisects AL. Is that true? Oh, it's by symmetry. Yeah, you're right. By harmonics. So XC and YB. Well, XC and YB. Yes, because the midpoint of the Similarity chord. Yeah, because if we take the midpoint of this chord, it's like perpendicular to AL. And so, yes, that's probably useful. Yeah, is there another point on this circle that we can use? So we know n prime is on it. Is there another point on it? OJ, yeah. Yeah, OJBDC is cyclic. The antipode of A has the same power to the two circles. All right. So instead of showing that O has the same power, we could show that A prime has the same power. Yeah, and then I kind of like that idea. Because then A prime B and A prime C are the distances, the radical axes. So we want to show that A prime B over A prime C is OG over, or OH over OG. Yeah, it's kind of equivalent. But yeah. I think we still need OH over OG, right? But I don't know, maybe it makes something easier.
I think that if we can prove that GH is perpendicular to OA, we are finished, right?
Yeah,
because that's obvious.
How do you know GH is perpendicular to OA?
No, I mean that if we have that, then it is obvious that we are done.
Okay.
Yes.
Making a mistake.
Oh yeah, no, it's all good.
And that is also like equivalent to those being cyclic because that is anti-parallel. So
It's equivalent to what being similar?
No, cyclic, G and M is cyclic
Oh
because
yeah,
that anti-parallel thing, O is perpendicular.
yeah, and that would prove it. But yeah, I'll just, yeah, let me see if it helps at all to draw in this circle that Konstantinos mentioned. Maybe we could use Casey's theorem on like these two circles. Let's see. So I don't think they intersect anywhere special though, like these two circles. Yeah. So n prime m prime is parallel to xy. I don't know if that helps. We have to at some point, we need to use that G as the circumcenter Bn prime A. So we know G lies on the perpendicular bisector of AB. How do we use that n prime as like on this circle with center G? Yeah, I think there's one more, probably at least one more insight we need here. So n prime j is parallel to ax, and m prime j is parallel to ay. That might help us a little bit. So I wonder if triangle AXY is similar to triangle n prime JM. I think it's likely that that's true. Let's check it out. Whoops, let me do it the other way. M prime.
Which triangles?
J n prime m prime and AXY.
Oh.
Yeah, those are similar. Let's see. And I think it's not that hard to prove. Yeah, I think it's just an angle chase to prove that. So yeah, a homothety at L takes, yeah, okay, it's kind of obvious. Yeah, homothety at L takes J n prime m prime to A x y. So yeah, J, so this is cyclic right here. And it also passes through O. So yeah, that circle is probably useful. And it's tangent to the big circle. All right, looks like Ryan is joining us. Hey, Ryan, thanks for joining. So we're on our second problem. I feel like we've made a lot of progress on it, but so yeah, we transformed it into a very different problem. So, sorry, there's a lot of information here, but basically we have the median AL, and then BX and CY are parallel to AL, and they lie on the circle. And then N and M are the midpoints of AB and AC. And originally we drew these two circles. So LNX and LMY. And we wanted to show that O lies on the radical axis of these two. But what I did is I did a little clever trick that I've used in a few other videos. When we have all these parallels, I reflected the whole problem across the perpendicular bisector of AL, and then it becomes equivalent to showing that O is on the radical axis of AB n prime and AC m prime, where n prime is the midpoint of XL and m prime is the midpoint of YL. So yeah, we transformed it a little bit. So yeah, that is what we've done so far. I wonder. Sorry. I want to see if there's anything special about like this point right there. Let me just check something. But yeah, I don't think there is. Okay, I'm gonna undo that. Sorry about that. So we could also, like, we could take the midpoint of LB and LC, and those should lie on this circle. So instead of the circumcircle of A, A n prime b. I'm just thinking, what if we take this circle and we do a homothety with ratio half? So yeah, so this is P and K. And we'd want the midpoint of, so yeah, what if I take the center of this circle? Is O the antipode of, no, O is not the antipode of L, right? I highly doubt that would be true. That would be a, oh, maybe it is. Maybe I'm just confused. Yeah, O has to be the antipode of L because the circles are tangent. So we take the midpoint of this, and the midpoint of this, then a homothety of ratio half, it takes this to the circumcircle J, JRK. So I mean, it's the same as showing that Q lies on the radical axis of JRK and JSP. No, that doesn't look right. What did I do? J. Oh, because S, I didn't define S right. JRK and JSP. Yeah, I don't know if that makes it easier. Maybe not. Like, I don't know if that's just doing a homothety for no reason. Okay. JSP. Yeah, it's interesting, but yeah, I don't know if it really makes the problem easier. I agree. Let me see, is there anything special about those circles? Don't think so. Yeah, maybe I'll just erase all those points. Yeah, I'm not sure how much the homothety really helps. We need to use that AL as a symmedian. I don't think we've actually used that. Like everything about the problem, I think we could have done. Like if AL were any chord, I think the whole diagram would be the same, right? So we need to use that AL as actually a symmedian. That's what's missing here. So X, Y, E, F, and BC are concurrent. I don't know if we could use that. Well, wait, so we want to show, if we show GH, we can show GHMN is cyclic, that solves it. Let me try this. So this looks a lot like a previous video on my channel. So these three are concurrent at a point. Wonder if we have other cyclic quadrilaterals. Like, is this cyclic? No. But EXGY, is that a coincidence? I could check F. Yeah, I think that's a coincidence. It's not actually true in general. I would be very surprised if that actually goes through point. Yeah. So, I mean, we could draw this point. I'm not positive how helpful it is, but this and then this. Okay. So yeah, the big question is how to use that AL as a median. So that's the same as saying ABLC is harmonic. Anything we can project through. So if we could reflect it all about, so I mean, it's the same as saying that A.
We have AXLY is harmonic.
AXLY is harmonic.
That. Yeah.
I wonder if RA and RL are tangent to the circle. Yeah, because once we know that that's harmonic, I think it's not hard to show that these are both tangent, right?
Yes.
Well, we know the two tangents have to concur with x, y. But does it have to be at point R? Oh, because we also know A, B, C, L is harmonic. So yeah, that has to be true. Okay.
I was thinking like at least intuitively we should sort of try to relate the point n prime with some angles, because like like thinking in terms of lengths, we probably want to evaluate OG, and for that, like since Bn prime is a fixed length and like Bgn prime is twice of Ban prime, so like if we can kind of find Ban prime, then we can like Like at least we should try to relate more the point n prime.
N prime.
Hmm.
So like angle BAN prime.
Yes, like I mean, like we have been working with the points x, y, and like for more.
We need, yeah, N prime somehow. I wonder. That's interesting. So these two circles look like they concur on the median. Let me check that, but it looks true. So let me draw it like that. So okay, so I wonder if it's, okay, so let's say we knew that A lies on the radical axis of these two. If we reflect everything over this perpendicular bisector, then we get XNA and YMA. And it's equivalent to showing, yeah, so like the median would go through all these. Let me see if that can help us. Yeah, I'm not sure if it really does. Yeah, I'm going to delete that, but that's kind of an interesting fact. It's a lot to this diagram. This reminds me so much of like this almost looks like another problem that I already saw on my channel, right? I can't remember the exact statement of it, but it was like very similar. It was like you have a chord, you draw two parallels, you have two circles like this, and you have to prove that a point lies on the radical axis. Doesn't this look exactly like that problem? It feels so similar. Let me see if I can find that problem on my channel again. And then somehow I did something that looks almost exactly like this, and then like I used the Sarg's theorem. I wonder if this is even like equivalent to that video. Let me see. It was problem 109 on my channel. And okay, in that problem I took the, okay, instead of AL, it was like, okay, it was like a little bit different. Like the parallels were the in circle instead of the circumcircle. And it was like AB, where D is the in touch point instead of AL, but it looks so similar. Like, let's see. Um, so yeah, really we need to find OG, and we need to use that, the circle goes through N prime. But yeah, in that video I used the Sarg's theorem. I'm trying to see how they did that. So maybe there's some other line through R. That's what I did. I used the Sarg's theorem to show there was like another line through R. You know what? If I let's try this. I don't think this will work. Yeah. Like maybe I could invert about R or something. So RA equals RL. And we know that this is cyclic. RAOL. One sec, I'll be right back. All right. Yeah, I'd really like to use Casey's theorem. And to do that, Yeah, but the thing is I need to know something about point G. So n prime m is parallel to xy. We have that homothety. Yeah, I think we use the fact that this is the symmedian by using the fact that x, y, b, c, and the tangents meet at R. I think that's how we use that AL is a symmedian. I just have to figure out where to go from there. So yeah, can we say anything about the perpendicular bisector of AI? So, which is the same as GH. I wonder if we have some cyclic quadrilateral like OJ. Well, this we know is cyclic. And we want to show GNMH is cyclic. I wonder, so construct the radical axis of OA and LNX. Okay, so LNX. Oh, does that circle pass through E? I guess, yeah, by symmetry it should, right? So, yeah. So basically you're going back to the original formulation, right? So sorry. What would I do? Yeah, sorry. Let me see if it's going to be a little tricky to draw. That point. Okay, so if I draw that, that's the radical axis. Do you have an idea what I should do next? Whoops, sorry. So NS, that's the radical axis of those two circles you just mentioned. Should we use Casey's theorem? Construct with LMY also. Okay. All right. So yeah, this is Ryan's suggestion. Okay, so it should be this point. Well, oh, wait a second, sorry. I think I drew the wrong point S. So I want the radical axis of this circle with L and X. So that should be point S, right? Because it's where, and then, okay, so I have this line, and then I have this line. I think that should do it. Okay. And then, so A and I would be collinear with that point, right? They should be. I don't know if I did this right. So you have L and X, L and Y. And then we drew this circle. So now I'm just confused. So let's see. Because like U should lie on the line AIO, right? Or no. If we take L, no, we want to show L, U, and O are collinear. Yeah, that would be equivalent. Okay. So yeah, let me know if you have any ideas doing it that way. Sorry, I know there's so much to this diagram now. Okay, so really we just want to draw NU and MU. And then we want, if we show L, U, and Q are collinear, that would solve it. But yeah, I wonder how hopeful this is. I mean, S, yeah. So we have RA squared is RJ times RO, right? I wonder, what if I let GH intersect MN? The point. Wait, do GH and MN intersect on the circle? That would be pretty significant if that were true. That's not true in general. So I wonder if there's anything we can say about this point right here. Because we want to show GHMN is cyclic. Is there anything we can say about V? I'm not sure that we can. Yeah, I don't think so. Although I don't know for sure. Okay. Let's do this for another like 10 minutes and then I'm going to move on to the next one. I'm going to hide these circles. Yeah, unless you find a way to use these circles, I think I'm going to hide them. Because yeah, I feel like if we can use A and B instead, it's probably easier. Wait. Let's point S again. So I wonder if there's anything special about this. So yeah, J n prime L m. So I mean, this is also harmonic, right? J n prime L m prime. So if we draw the tangents, like this should be tangent to AJ, or this should be tangent to that circle. And AM and AN should be tangent to this circle. So I don't know if that helps. So yeah, these are tangents and these are tangents. So if that's tangent, then can we say anything about this? Wait, why isn't that cyclic? These are both tangents. Wait, what am I doing here? So J, N prime, L, M prime should be harmonic, right? Those should both be tangents, right? Am I missing something? Oh. Okay, so I think we know the tangents concur on AL, but we don't know that AN and AM prime are the tangents. Oh, that's what I did wrong. Okay. We just know that they concur somewhere on AL. Out of curiosity, let's see. I wonder. We do know that this is cyclic. Does it? I think that's a coincidence. I don't think it actually passes through energy. Yeah, it's a coincidence. Let me draw this again. RAOL. I don't think these actually concur. Actually, it almost looks like All right, 2 more minutes and then I'll move on to the next one. I thought we were getting there, but then it was harder than I thought. So yeah, so what if I do this? What if I draw the midpoint of BC? Just T. And I try to do this. No, that doesn't do much. So GH is supposed to, we want to show it's perpendicular to OA. Like what if we draw the triangle whose sides are perpendicular to OA, OB, and OC? So yeah, like what if we completed the figure? So just one last ditch attempt. Oh, that is, I mean, basically we want to show GH is parallel to AR. I don't know how I missed that. That's what we want to show. We want to show GH is parallel to AR, right? And let's see if there's any last ideas. I don't, sorry. All right, I think I'm gonna move on to the next problem. So here's an easy one. Looks easy, but I just want to solve a problem. So